Hello, I am Brandon Burkhart, and this is my final for EE151. It is a micro advanced weather station with GPS and Bluetooth. So you can see that it's fitted in only two regular sized breadboards, and I am using an Arduino Nano, which the reason why I'm using this is because it's cheap. It has the same microcontroller as the Arduino Uno, which means it has the same amount of pins, but it is much smaller, less power or more power efficient, and it fits directly on the breadboard like this. I'm also using compact breadboard wires just to clean up everything. So the biggest thing you can see on here is the massive LCD screen, which is currently displaying the current time, date, temperature in Fahrenheit, humidity in percentage, as well as the luminescence in percentage. So because of that, I have a few sensors. I'm using a Neo 6M GPS module, the DHT11 module that's in the Arduino kit, and a photoresistor. The photoresistor is simple. It just controls the luminescence. So you can see right here that if I move my hands away, it's around 70% indoors right now. And if I put my finger on it, it goes down to about 0 or 1%. And then if you're outdoors, it'll be 100%. So it could tell roughly what that light is right now. So, and then the DHT sensor is currently reading the humidity as well as the degrees in Fahrenheit. I can use the conversion from Celsius to Fahrenheit because most people use Fahrenheit in the US. Another thing that I'm using is a potentiometer and a few resistors just to control the screen brightness and some other stuff. You can see here that I have a green LED currently on. This is actually an RGB LED. Currently it's green, which signifies that all sensors in a GPS is currently working. If it's cyan, all the sensors are working except for the GPS, and if it's red, nothing is being read. So it's green, which means it's good. And as well as you might be able to see on the Arduino Nano, the RX pin the TX pin is blinking, which means that it's correctly sending information of a GPS or the Bluetooth. And this on the GPS module, this red LED is on, which signifies that the GPS is on. So we have two buttons here, which I'm using interrupt functions for. If we press it, actually will change the current display on the LCD. So currently it's on what's called the main page. If I click on it once, it will display the latitude and longitude because it has GPS with it. And if I click it again, it will show me the time again, the number of satellites that's currently connected to. It tries to process the speed. This actually comes directly from the GPS data, so I actually didn't have to do any math for that. And then as well as what it thinks its current altitude is, just based off of math that comes from the data too. So one thing I really wanted to do, which I was able to successfully do, was these two buttons are actually have debounce programming in it, which means that in the Arduino program, it's actually programmed to only recognize a press, I think it's every fourth of a second, so there's no bouncing and gibberish that you usually would get for a normal button press. And then what's cool about the time and all that, and the date and all that stuff, is that it's actually coming from the GPS itself, which means all 8 satellites are sending the data to it, and it's syncing it up, which means that instead of a real-time clock or storing the time in an Arduino, it's actually currently being updated via an atomic clock, which is what the satellites get their information from. And then I can't really show you because I'm recording my phone, but the GPS module would actually connect to a phone app. It's just a serial app. I didn't custom program anything for that, but it uses Bluetooth LE 4.0, which is actually the current and fastest Bluetooth for phones. And it's sending basically the same data you see on the LCD, but on the phone, with a few extra things, like it has seconds and it has some signal stuff with it. Some challenges I encountered with this is I originally wanted to use the BME 280 sensor instead of the DHT11, but this actually, I didn't have enough pins for this to be able to use the BME sensor because that uses I2C, and I actually didn't really have enough pins to use that. So this one only uses one digital pin, which is why I went with it. The GPS module also uses RX and TX, so it uses just standard UART communication. So I just have a link to currently Digital 12, and I have a program of software serial in the library. And then the Bluetooth is directly connected to RX and TX of the Arduino, so which makes it really easy because this module, all I had to do was custom program it in a separate Arduino program with some what's called AT commands, which is what most UART devices use that can be programmed to use. And so I have a custom program to display stuff like the current baud rate, how it should connect to phones, what should the name of it be when displaying to phones and such. And it's able to be directly connected to, like I said, the RX and TX, which means that all I need to do is the standard serial.print or serial.print line, and it'll actually automatically write to the phone, which is quite nice. I don't have any I have it hooked up for receiving, but the Bluetooth does not receive any information, or it's not supposed to, from the phone. It's just meant to be from this module to a phone. But in the future, it would be nice to be able to ask it information from the phone to this and then have it reply back. But I don't have it currently hooked up. I like how small it is. It was quite difficult to actually get the wirings correct, and actually this compact for also having the LCD, the Arduino, and then also all the sensors and stuff. And so that's my project for EE151.